Hello, this is Jack Jackson back again with part 2 of our lectures here on problem solving and applications of linear relations. This is all coming from the same PowerPoint slide. Today we're going to be looking at number puzzles in our system, in our effort to illustrate how we can use this problem solving techniques as they apply to linear equations. So remember, we talked in our last video about a 6-step problem solving technique to solving application problems. Step 1 was to read the problem just to get a basic understanding of the problem. Step 2 is to reread the problem and organize the information as we go. We'll write down the known and unknown values either in columns or in a chart or table of some kind. We'll identify the things that we do know and put the numbers with them and the constants and identify them in words. And we'll also identify things we don't know, and we'll either give them a variable or a variable expression, identifying what the variables stand for. And while we're doing this, usually we'll draw some kind of picture or graph and label its parts. Sometimes that part is optional. Then we will write a formula or equation or inequality or system of equations. Using our knowledge of the subject matter, we'll write this relationship, probably first in words and then with equations. With mathematical symbols. Next, step 4, we'll solve the formula, equation, inequality, or system for all the unknown values, and then write down the answer in step 5. We'll write down the answer in a sentence. We may have to interpret our answer in the context of the problem. We may have to, in steps 4 and 5 there, we may have to find more than one thing, and so we'll have to find all of the appropriate things. And then finally we'll check, first of all, just to make sure it makes sense, that it basically makes common sense in the context of the problem, and then also that we get an exact check, so we'll go back to the original problem with our answer in hand and check it from the original logic. So let's look at some real simple examples here to get us started with this process. 3 more than twice the number is 15. What is the number? See if you can solve this using the 6 steps. Press pause now and come back. Okay, now that you're done, we're back and we see the step 1 is just read it. 3 more than twice the number is 15. What is the number? Step 2, well, there's not a lot to introduce here. We're just going to introduce a variable for the number, so let x equal the number. That's the only thing there is in step 2. Step 3, write an equation. 3 more than twice the number is 15. Is the equals. 15 is on the right side of the equals. 3 more than means we're going to add 3 to something. We're going to add 3 to what? Twice the number. That's 2 times the x. So we have 2x plus 3 equals 15 is our equation. Now simply solve that equation by adding negative 3 to both sides to get 2x equals 12, and then dividing both sides of the equation by 2 to get x equals 6. So remember, since x was the number, step 5 is the number is 6. Notice that it's answered in a sentence. Twice 6 is 12, and 3 more than that is 15, and that's what we need, so that checks. Pretty simple example. Probably could have easily done this without writing it all out in these steps. Probably could have even worked this one in your head, perhaps, or with just a little bit of scratch paper. But what we want to do here is we want to learn this method. Okay, here's another one that's kind of similar. The product of a number in 7 is 42. What is the number? Go ahead and work this out, showing each of those steps. Press pause and come back when you're ready. Well, step 2 again is just let x equal the number. The product of a number in 7 means 7 times that number. 7 times x is equals 42 on the other side. So we get 7x equals 42. Easy to solve. X equals 6. Just divide both sides of the equation by 7, and so we see the number is 6, and sure enough, the product of 6 and 7 is 42 as needed. 1 more than 3 times a certain number is 17. What is the number? Okay, by now you've seen a couple of illustrations, so definitely you should be able to do this one on your own and show all the steps as we've done it here. Please do this now. Whoops, I don't have that one worked out. 3 times a certain number is 7. 1 more than 3 times a certain number is 17. What is the number? I'll let you work that one on your own. Let me go on to the next one. The sum of three consecutive integers is 54. What are the integers? See if you can work this one out. Press pause now. Well, there's a little more involved in step 2 now. Notice that consecutive integers are 1 apart. So if we let x equal the first integer, then x plus 1 is the second integer, and then x plus 1 plus 1 more, or in other words, x plus 2, is the third integer, and the sum is 54. Notice that we have the variable or variable expressions on the left lined up the equals in the middle, and lined up in words on the right. So it's a way of organizing this step 2 is very important. Now the sum just means we add them up. So first integer plus second integer plus third integer equals the sum. Notice I've written the equation out in words, and now I simply substitute in. The first integer is x, the second integer is x plus 1, the third integer is x plus 2, and the sum is 54. So now I have my equation. Now solve that equation by combining like terms on the left. X plus x plus x is 3x, and 1 plus 2 is 3. So we get 3x plus 3 equals 54. Now, so we've simplified the left side, and the right side's already simplified, so subtract 3 from both sides of the equation to get 3x equals 51. Divide both sides of the equation by 3 to get x equals 17. Now let's figure out, so x is 17, that's the first integer. The second integer is x plus 1, so that's 17 plus 1 is 18. And the third integer is x plus 2, so that's 17 plus 2, that's 19. So the integers are 17, 18, and 19. Now first we have to sort of check to make sure this makes sense, because these are supposed to be integers, and sure enough, 17, 18, and 19 are integers, and they are consecutive integers. And then the final check is to make sure that their sum is 54. 17 plus 18 plus 19. Yep, that's 54. And so that does check. How about the sum of three consecutive even integers is 48? Based on the last example, you should be able to work this one out. Go ahead and work this out now. Press pause. So consecutive even integers are 2 apart, not 1 apart like consecutive integers. So we're going up by 2's. So again, if we let x equal the first integer, this time the second integer is x plus 2. And the third integer is x plus 2 more, or in other words, x plus 4. And then the sum is 48. So you can see the information represented there in step 2. Step 3, we see that the sum is the first integer plus second integer plus third integer equals the sum, and substitute in what we have for those. We have x plus 2 plus x plus 4 equals 48. Again, simplifying, on the left we get 3x plus 6 equals 48. Subtract 6 from both sides, we get 3x equals 42. Divide both sides of the equation by 3, we get x equals 14. 14 is an even integer, so that's good news. And so if we add 2 to that, we get 16, and add 2 more to that, we get 18. And so our integers are 14, 16, and 18. Notice those are integers. They are even integers. They are consecutive. So it meets all those criteria. So the only thing else we have to try to make sure is that their sum is 48. And sure enough, when you add 14 plus 16 plus 18, you get 48. The sum of three consecutive odd integers is 54. What are the integers? Work this one out. Press pause now. So if they're consecutive odd integers, they're also 2 apart. So we set it up exactly like the consecutive even integers. Let x equal the first integer, x plus 2 the second integer, x plus 4 equal the third integer, and 54 equals the sum. So we get x plus 2 plus x plus 4 equals 54. That's step 3, the equation. Step 4 is solve the equation. Simplify the left side. 3x plus 6 equals 54. Subtract 6 from both sides, we get 3x equals 48. Divide by 3, we get x equals 16. 16 is an integer, and then the other two would be 18 and 20. The problem is that it's not an odd integer. And so actually this problem has no solution. This is an impossible situation. So we would say there's no solution. In fact, you might have even noticed that there is no solution to begin with if you think about it a minute. If you've got 3 odd numbers and you add them up, 2 odd numbers adds up to an even, and then an even plus an odd number adds up to an odd number. the sum of any three consecutive odd integers has to be an odd number. It can't be an even number like 54. So there's no solution to this problem. However, we did find that there are three consecutive even integers whose sum is 54. 16, 18, and 20 are consecutive even integers, and their sum actually is 54. But that doesn't fit the criteria of this problem. So this problem actually has no solution. Alright, how about a little age puzzle here? Al is twice as old as Bob. Joy is 5 years older than Bob. The sum of their ages is 37 years. How old is each person? See if you can work this out now. So little number puzzles like this are fun. But notice what we're going to be looking at. We're going to be looking at Al's age, Joy's age, Bob's age. And so we can work this out like this. Al's age is, let's see, Al is twice as old as Bob. So I have to let one of them be our variable. Okay? When you see Al, basically it says Al's age is 2 times Bob's age. That's another way to rewrite that first sentence. So when you see Al's age is on the side of the is equal to, by itself. Let the other one be x. So it's easier to let x be Bob's age. Now, then the first sentence tells us that Al is twice as old as Bob. That says Al's age is 2 times Bob's age, so Al's age is 2x. Now, Joy is 5 years older than Bob, so since we already know Bob's age is x, whatever that's going to turn out to be, Joy's age then is x plus 5. So now we have a variable expression for each age that agrees with the first two sentences. Also, I should have written here, the sum is 37, so I should have written 37 equals the sum of the ages. And that's how we get our equation. 37 equals 2x plus x plus x plus 5. So combining like terms there, on the right we get 4x plus 5 equals 37. Subtract 5 from both sides to get 32 equals 4x. And then divide both sides by 4 to get x equals 8, or 8 equals x. So then 2x is 2 times 8, which is 16. That's going to be Al's age. X is Bob's age, so that's 8. And Joy's age is 8 plus 5, x plus 5, which is 8 plus 5, or 13. So our solution is Bob is 8 years old, Al is 16 years old, and Joy is 13 years old. Let's check this out. It says Al is twice as old as Bob. Yeah, that works out because 16 is 2 times 8. Joy is 5 years older than Bob. Okay, 8 plus 5 is 13, so that checks out. And then the sum has to be 37. 8 plus 16 plus 13 is 37. So that's good, that checks out. Alright, how about this one? Bob is 7 years older than his sister Sally. In 4 years, he will be twice her age. What are their current ages? Now notice this time we're going to, if we make our list of things that we know and need to know, we're going to have Bob's age now and Sally's age now, and we're going to have Bob's age in 4 years and Sally's age in 4 years. Because of the way this is organized, it's going to be better to put this information in a table. See if you can use a table to organize this. Work this out if you can and come back. Press pause now. So notice that we have the two people's ages at 2 different times. So we can have a 3-column table. The first one has the name of the person, Sally and Bob. And then we have their age now, which is, of course, in years. So Sally is X years old now. Bob is X plus 7 because Bob is 7 years older than his sister Sally. So right now he's 7 years older than she is now. So X is her age now. Bob's age right now is Sally's age now, X plus 7. Now in 4 years they're going to be 4 years older than they are now. So Sally's age in 4 years will be the X plus 4. Bob's age will be X plus 7 plus 4, which simplifies to X plus 11. Now, so far, this is just setting up ages now and ages in 4 years. Now, how do we get an equation out of this? Well, the second sentence tells us the relationship that will set up our equation. In 4 years, he will be twice her age. In other words, rewrite that another way, it says 2 times Sally's age in 4 years will be equal to Bob's age in 4 years. Not twice their ages now, but twice their ages in 4 years. Sally's age in 4 years is x plus 4, and Bob's age in 4 years is x plus 11. So this becomes the equation 2 times parentheses x plus 4 equals x plus 11. So we simplify using the distributive property on the left to get 2x plus 8 equals x plus 11. Subtract x from both sides to get 2x plus 8 equals 11. Subtract 8 from both sides to get x equals 3. So x is 3. X plus 7 is 10. 3 plus 4 is 7. And 3 plus 11 is 14. So we see that currently Sally is 3 years old and Bob is 10 years old. In 4 years they will be 7 and 14, and sure enough, twice 7 is 14. So this is a good example of showing you something where we have a table set up for our part 2, step 2. And these tables can be extremely useful. Alright, let's take another example here. A 45.25 inch long board is cut in 2 parts so that 3 times the length of the shorter piece is 5 inches less than the length of the longer piece, and assume that there's a 1/4 of an inch. Okay, press pause and try to work this and come back. Well, first of all, in a real-world problem, when we cut a board, some of the board ends up as sawdust on the floor. Okay, and so in this case we're assuming that basically we've got a pretty thick blade here, and it's going to consume a 1/4 of an inch of board. Okay, and so we start with 45.25 inch long board. The 1/4 inch is consumed, and we're left with 45 inches of board in 2 parts. Now, one standard technique when we have 2 quantities that add up to total is let one quantity be x, either board that we end up with, and then the other quantity will be the total minus x. And so this is a standard technique that will be used. And in this case, all measurements are in inches. Notice that when I have a real-world problem, I should go ahead and somewhere be sure I say something about what units are involved. So 45 inches is the total length. That's after the waist, of course. X equals the length of the, say, the larger piece, and then 45 minus x could be the length of the shorter piece. Okay, so the equation says, let's see, the problem says 3 times the length of the shorter piece is 5 inches less than the length of the longer piece. Okay, so remember the is the equals, so replace that with an equals. Let's go to the left of the equals. 3 times the length of the shorter piece is. It's 3 times the length of the shorter piece. The shorter piece is 45 minus x, so we have 3 times parentheses 45 minus x is the equals. On the right side of the equals, we have 5 inches less than the length of the longer piece. When you say 5 inches less than, it's that other thing minus 5. So we're subtracting 5 from the length of the longer piece. The longer piece is just x. So the right side is just x minus 5. So there we have our equation. 3 times parentheses 45 minus x, close parentheses, equals x minus 5. Use the distributive property on the left to get 135 minus 3x equals x minus 5. Add negative x to both sides to eliminate the x on the right, leaves us negative 4x on the left. And subtract 135 from both sides to eliminate that from the left, which gives us negative 140 on the right. Divide by negative 4 and we get x equals 35. Then 45, so that's the length of the larger piece. The shorter piece is 45 minus x, so that's 45 minus 35 is 10. And that's everything's in inches. So step 5, the 2 pieces are 35 inches and 10 inches long. And notice if you add the 35, the 10, and the 1/4 inch waist, we got our original 45.25 inch long board. 3 times the 10 is 30, and then that's also 35 minus 5 is also 30, so that checks out. So we've seen some examples of some number puzzles. Now, in our next couple of videos, we're going to work through some more, maybe some more interesting problems. But now we've got a kind of feel for how these 6 steps work. Hopefully we can apply these in a little bit more interesting problems. The next one we're going to look at some velocity applications.